Hello everyone. I hope you are doing extremely well. So today we are going to discuss a very interesting and a very technology heavy service that is being known as like Google Ad Engineering Service. So uh, like this particular discussion is primarily based upon how the ad aggregator services like Google and Facebook work under the hood, and how do they generate the billing, the purchases, and the separate kind of a report for their end users. But before we go into that aggregation service, there are lot of important terms we need to understand to appreciate the system at scale. So for example, when a smartphone campaign, like suppose Samsung or Apple, they are releasing their latest version, how that particular smartphone ad campaign will run, if we can just understand that, probably we will be able to appreciate the system in a way better way, in a way better sense. So let's take a scenario. The scenario is something like a smartphone campaign is running on for different smartphone campaign for Google search trends. Okay, Google search ads are going on. Suppose somebody is like in the search box, in the Google search box, in Google, somebody is writing something like uh, best smartphones of uh, 2025. Okay, so the moment you search this, you will see that there is a number of ads are also coming alongside. There are some articles. So who controls this ad, and how these ads are coming onto your web page? That is the primary point of discussion. So suppose somebody is running like Google, Samsung or Apple, they are running a ad campaign. And when I say ad campaign, when I say ad campaign, how it runs is, suppose they will tell that m- provide my ad when this particular search for smartphone is going on, when smartphone search is going on, maybe on some price range or some location. There can be multiple points around this, and run it for duration, and the duration of 30 days, and there is a certain budget. Okay, budget, like I'm just writing a dollar just in case. We know we, we we are not zeroing down to any cost right now. We will try to see what exactly comes there. So the most important term here is the real time bidding. Okay, so RTB or real time bidding. So we need to understand how real time bidding work under the hood. So when a user searches by that best smartphone of 2025, okay, suppose a certain user, he searches the best smartphone of 2025. Okay, and Google Ad Exchange runs a real time auction in milliseconds. So what the AdSense will do, suppose this is my AdSense, Google's Ad Exchange, Google's Ad Exchange server. So Ad Exchange server determines in a single millisecond what we should be showing it to in a 1 millisecond time, which ad, like be it Samsung or Apple, which ad we are going to show it to the user. Okay, so suppose there are two competitors, like Samsung is there in the real time bidding. I will go more detail of real time bidding, but let's understand into this thing for the time being. Suppose Samsung is there, it is bidding that I'm going to give 2.5 dollar per click. Okay, per click. For example, if you show my ad and if user click, I will give you $2.5. And at the same time, Apple tells you like, okay, man, I'm going to give you $3.0 per click. Okay. So now uh, definitely Apple will win this bid. And how the CTR, like here we have written one more term, CTR. How CTR will be calculated is the percent of users who click the ad after seeing it. So suppose there is like out of 100 users, only 10 people have uh, clicked on it. So when we are showing some ad to end users, that is being known as impression. So it is only coming up in user's timeline or user's web page. That is being called impression. And when user clicks it, that is become a click against this impression. So how CTR is being calculated? CTR is click divided by impressions. So that is how CTR is being calculated. Okay. So suppose there are like 1 million impressions are being shown. Out of that, 15,000 clicks are there. So that means the CTR will be somewhere around like 1.5%. Okay. So 1.5 percent CTR just is a like, just FYI, it is a very strong in terms of the search, and the ad conversion. So that's a very good search. Like if I'm getting like 15,000 against 1 million, against 1 million. Okay. So now let's talk about another very important term like CPC. So CPC means the cost per click. Cost per click is the same thing that we have been just discussing here. So this is basically nothing but cost per click. So now how the mathematics is being done is that for cost per click, I am spending $2 or like maybe 2.5 some dollar. Okay, suppose I'm taking it as $2. So that means my total expense is 30,000. And so out of that, how many have actually converted? That is being known as CVR. Okay. So suppose out of 15,000, 450 have actually taken it. So that is close to somewhere around, I think 450. Yeah, it will be around 3%. So it will be around 3%. So and whatever my profit cost is, suppose it is a $600 smartphone. Okay. So 450 conversion star $600, that is like $270,000. Okay. And my cost was, and you can see my cost was $30,000. So this is how ROI and everything is being calculated. And how Google like does the billing is like it tracks against every ad that is being placed. It logs for every click via the user parameters. And the for example, there can be bot clicks or something like that, right? So there are machine learning traffic detections are in place in Google which can detect it. Okay, so let's do a little bit of deep dive how like how the RTB actually happens behind the scene. So again, this is just so that we appreciate the system a little bit more. So RTB with a detailed example, suppose. So suppose Samsung is via their DSP. DSP is nothing but demand side platform. So via their demand side platform, what they do is they are bidding something for $2.5 per click. Okay, and Apple is having $3 per click. Remember, this is the max. Okay, so suppose Samsung says like per click max, and Apple will say that I'm going to bid for $3 per click for max. Now, a publisher, so a publisher, suppose something like a TechCrunch website. Okay, so TechCrunch is a very popular startup people's website, or some Ivy League or some Ivy League related medium articles are there. Okay, so in all those cases, those beings are known as the uh, supply side platform or SSP. Okay, so here is like DSP and SSP. Now, once a user comes to TechCrunch, what will happen is our supply side, our SSP will initiate a bid request. How this bid request will look like? So this bid request will have a lot of user demographics, like user demographics without by anonymizing the user, of course. Okay, so what they will do is they will send the location, they will send the device from which it is being done. They will also share the browsing history, like some of the cookies data, and they will also do some kind of a age profiling, like age 28, and some kind of profiling like take enthusiast, or uh, like gamer, some sort of a thing. This kind of a user demographics it will send. Now this ad exchange, after the ad exchange get this data, so what this ad exchange will do now, suppose this is our Google Ad Exchange. Okay, Google Ad Exchange. Okay, so this Google Ad Exchange, what it will do is it will send it to different DSP. So suppose there is this DSP. Okay, and for Samsung, it will also send to DSP of another DSP of Apple. Okay, and now it is the responsibility of the Samsung and the Apple that what will be their bidding cost. Now, based on this device, this browsing history, suppose Samsung determine that like it has some kind of a machine learning algorithm in place, and that machine learning algorithm determines, okay, the user is already a Apple or a iPhone user. It is not very likely that a high-end iOS user might shift to Samsung. So they will say ki, okay, we are not going to make a bid for it, or we are going to have a minimum bid like $0.2 or something, or if there is a minimum bid, they will do that minimum bid. Okay, and Apple sees that, okay, this is a iPhone 15 user, and now iPhone 16 is coming up, so it will be a good investment for me if I just make a larger bid. And what I am going to do is I'm going to make a bid of $2.8, suppose. Okay, considering that this is a Apple user, and I will send something like iPhone 16 upgrade is available in some dollar. Okay, so these algorithms analyze the user data, the search history, and make a bid value. And this ad exchange then runs a second price auction. What it will do is, suppose there are other auctions are going as well. Suppose it has even sent something to few of the popular like furniture stores. I don't know, maybe it can be something like some bookstores as well. So after that, what it will do is, what it does is like what Google Ad Exchange does is it identifies the highest bidder, and from the highest bidder, what it will sorry, it will identify not the highest bidder, it will identify the second highest bidder and the highest bidder. Okay, so from that two, what it will do is, for the highest bidder, it will assign that particular ad, assign and display. And what it will do is the cost will be second highest bidder plus $01. Now this is a very interesting way, like only 1 cent is added against like the next lowest bid. So Google Ad Exchange is not going to rob you the money. Rather, what they will do is they will see what exactly is the lowest bid that has been the second, like just lowest, like, or the second highest bid, and it will just add zero point 0.1 cent to on top of it. Okay, and this is how the ad is served. The Apple's ad that upgrade to the iPhone 16 or iPhone 15 Pro, this thing will be displayed, and the whole thing that I wrote till this point, this whole operation, it is a sub second. It is a sub 100 millisecond operational time. The whole process, the most fascinating part is it runs less than in 100 millisecond of time. And when user clicks on that, that's a completely different story, which we will explore now. Now, as you can understand that RTB is super fast and automated. That algorithm evaluates the bids in real time and the user data in real time, and user data that derives the bid based upon the machine learning algorithm. Okay, and suppose the key and like the cookies and the device ID, those things are also one of the very key element in this Google ad exchange and the data exchange. And probably now you have some idea why Google does collect all of our data. It is only to make sure that that particular data is available for this RTB to the different to their different customers. That is how every voice statement that we make, or every single place that we go, we start seeing our ad in different platforms uh, of with that relevancy. So they keep on getting our data and consistently feeding the data to the DSPs. Okay, so this is how uh, it works. And as you understood, the Samsung or any advertiser, they determine the bid using the automated algorithm. So this dollar, like for one single ad, it can be point 0.2, and their machine learning algorithm based on the next user demographics input can determine, oh no, I need to bid for $2.5 at least. Suppose Samsung Galaxy Note user, and Samsung Galaxy is launching a new pen. So in that case, this machine learning algorithm might be just make the highest bid as per that. So the factors that influence this bid amount is like the predicted revenues of the users, and of course the probability of click and the conversion. There is a lot of maths involved in this purpose, and I think we got a fair bit of idea how the whole system comes in play. Now we understood that there are now let's talk about the next part. So now we understood there are things like SSP, right? And there are things like the supplier side platforms, and then there are things like DSPs, demand side platforms, and then there are from there RTB are being determined. And after RTB, after this process is being done, once user clicks the ad, how the data, how the ad is being stored, and how the ad owners can derive analytics analytics from there. That is my that is going to be our point of study here. Okay, so rather than going into designing, like this real time bidding is completely different kind of a process. It is, although the more we go deep dive into it, we will find it is end of the day machine learning and some data engineering involved here, but a very interesting design here is how the data aggregation is being done once the user clicks on the ad, and how the reporting pipeline for that ad performance, like how my ad has performed, how my ad has performed, uh, how my campaign is, what is the best performing ad in my campaign, in which age group my product is being my product is being most clicked or visited. Okay, all this kind of answers we can actually derive from our uh, click ad click aggregation pipeline. So the system that we are going to build is basically how to store the ad click data, and how to derive analytics from it. That is my primary purpose. Okay, suppose again, just to take the easier example, if the user clicks on the Apple ad into the TechCrunch website, which we took that example, the click event is sent to our aggregation system, and system then runs various aggregation and gives user a lot of insight uh, for that particular data. Now the next thing is how data will come to our system, right? So how so now that we know like our problem statement, okay, so this thing basically is our problem statement, okay. So let's discuss like how in this kind of system, once user clicks on an ad, how it comes to our system. Okay, on a very high level we will definitely do a deep dive. So um, once a user clicks an ad served via RTB, the ad exchange, so there is a user. Suppose there is a user, okay, and this is basically my ad exchange. This is basically my ad exchange. What does that user will do is, after clicking, this ad exchange will generate a click event. Okay, this ad exchange generate a uh, generate and records that click event with some attributes, like it will take that ad id, so ad id or ad campaign id, it is the click timestamp. It will also take something like, in case we have some sort of a data of the user or user info, I would say, not exactly the user id, because this ad events are not supposed to expose users PII or personal identifiable information, the user's IP and user's country. Okay, it have all this informations. So now how we are going to track it? So suppose there is a certain URL, and in that URL we are going to pass it, maybe, like, I'm just oversimplifying the system now, maybe something like ad id equal to 123, and the timestamp equal to some kind of epoch timestamp we can pass. Okay, so this is how we are going to pass, and it is going to get stored in some sort of a database. We will again go into a very detail what kind of a database we are going to make this data store. Okay, but just for the time being, take it here that we are going to store it into our database, and there will be a certain, like in this database probably we will create our own visualization and our aggregation, which will give user. So at the last part what we'll have is, it will have our aggregation and visualization. Okay, aggregation and visualization. So the system needs to support, suppose this system, what you see, what this needs to do is this needs to support uh, some basic queries. When I say basic queries, like it may be something like return the number of click events for my ad ID in last 24 hours. Okay. So return top 100 click ads in a certain city, in a given city, or some other demographics. And also like custom filtering, suppose user is having lot many aggregated data, so based on like custom filter based on the user ID, uh, based on the country, uh, based on the user ID country, and there can be many other things like IP region, range, state, age of the users, many things we can use for our custom filters. Okay. And what is the kind of a latency we might have in this whole process? So this is not a sub millisecond latency we are going to have, because the moment user clicks onto something, we do not need to show it immediately to the user, even like uh, uh, 5 minutes, or like maybe 120 seconds of 120 seconds of delay is acceptable on upper limit, but we will try to make it like somewhere around 60 second. Okay, but this is, we will try 60 second, but we will see why 60 second is different. Like 60 second is little difficult. While we go into the complete high level design, it has to come through certain pipelines of data. So that is a point of other discussion. So now that we have this basic data, that what will be our output of the system, what will be our latency of the system. Let's talk about, like, if somebody like when the click event occurs, what are the primary endpoints of our system. Why endpoints are important? Because using this endpoint only, like using this, suppose there is a Google Ad Exchange server, right? Google Ad Exchange server will tell you that you use my endpoint and you send this payload, then only I'll be able to store. So suppose for a certain given ad ID, I want the aggregate count, like what is the number of clicks that happened. So Google might have given me this kind of a endpoint, aggregated count. Okay, Google might have given me this kind of aggregated count, and it will tell that you send me a payload or request parameters with something like from to filter. Okay, and the response that they are going to send is like ad ID and its corresponding count. Okay, so this is one of the endpoint. And also suppose the top, this is like aggregated count endpoint. And then suppose there is another one more, like top m most click ads. Okay, so we can have something like ads by age group under 30. Okay, so we can have something like ads, popular ads, and in our payload we might be giving something like custom filter. Okay, that custom filter with age something like less than 30. Okay, uh, and there are some other demographics as well. So in this way we can have like multiple endpoints based on some of the users requirement. Now what are the business use cases this endpoint might serve? So suppose as a product manager, I want to see I want to see and analyze the click trends to allocate the budget effectively. Like if I am targeting US users, and if US users are perform poorly, I will shift to Canada, and I will try to see if I'm relocating budget to that Canada region or Mexico region or into a Europe region, whether it is serving well or not. Suppose again, advertisers can check how many clicks for a specific ad it is happening by using that aggregated count. So this kind of analytics data is very, very important, or I would say is the heart of the system of any design decision that the advertisement owner is going to take. Okay, so now let's talk about the data format in which we in our aggregation service going to store the data. Okay, now this is again a very important point. Suppose there is a lot of raw data out there. Okay, so raw data represents unprocessed click events that are logged in the system, like ad id, then the click timestamp, then some kind of a user info, IP and country, which we discussed earlier. And all this auditing, like the for raw data is very important to store in terms of the auditing and the debugging purpose, and the raw data serves as a source of truth as well. And if the aggregation has to run, the aggregation definitely has to run in different scale based on the raw data. So raw data is our very primary source of truth which we are going to have. Now let's think about some kind of a filter table. Okay, now when aggregation comes in play, so again this is of course a raw data, and when aggregation comes in place, aggregation like give me some top m data of given filter. So like aggregated data, for aggregated data we already saw what kind of APIs are there. And when we are having this kind of ag- this kind of aggregated data already sitting in our server, it makes our querying really easy. So suppose to support queries like top 100 most click ads in the last m minutes, we should maintain a separate structure like some kind of a window size, the size of the aggregated window in minutes. Like for example, I will just write this thing, some kind of a window sized data. Okay, so like last 5 minutes, for last 5 minutes I will run some kind of aggregation, and in that 5 minutes what is the most clicked ads. Okay, so example JSON will be something like this. uh, a window example JSON will be something like this: for a window size 5, the updated timestamp, and what is the most click ads in that particular time. So this is known as aggregation. Now why do we need, now you might ask the next question like, man, I understand all these implications, but why both raw and aggregated data we are going to need? So like the first thing is that the raw data is going to be our source of truth. Any kind of aggregation that we are going to run, it has to be based on the raw data. Any kind of auditing we need to do, suppose an advertiser comes and disputes that the number of click reported, you have bloated the numbers, but what I have seen is only like instead of probably 1 million, there probably were only 500 clicks were reported as per my system. So we can show them the raw data for the for this kind of auditing purpose. And of course there is some part of the compliance, and data science or the machine learning team also sometimes they prefer to have the raw data to understand to and raw data and to clean it up to understand what exactly they should be using across the system. Okay, so now the main challenge of the raw data is of course the cost, and the query performance also will be very slow because you will be directly querying tons of tons of data. Maybe a data lake sort of a place you need to query, which is really going to be slow. And aggregated data is needed because aggregation will give you the primary purpose of the system, that is the billing and the reporting. It will tell you that okay, in the last 24 hours or in last 30 days when you have ran your whole campaign, this many number of clicks have happened, so pay us this much amount of money. And also like for the RTB or the real time dashboards, this is like top hundreds or having custom filters across the raw data. Having aggregated data is very important. So this is probably I hope it is clear like why we are going to need aggregated data and the raw data both. So now let's talk about the choosing the database for us. Okay, so choosing the database. So at first we have been talking about the raw data, right? So raw data is nothing but like all this ad id, all this data, right? The all the ad id, all the click timestamp, all the user info, IP and the country. So this is end of the day, if you see, this is kind of a time series data, right? So and what kind of workload these are? If we just look into the workload, this is this workload are like write heavy and moderate read, we can say. Okay, so the average write heavy and the light read, I can say. And if I have to do like a write query per second, write ops per second, so probably like 10,000 data from different source might come, and peak might be somewhere around 50,000. And so daily volume we can expect something like 1 billion. Okay, and that will come to somewhere like 100 GB per day. That's a good amount of data. And the read wise it is going to be really light, so we do not have to worry a lot about that. And this data in our raw data will be hardly queried directly because we anyway will give a consolidated dashboard to our users, and these queries will be mostly batch oriented. So this will be our base data for our aggregation and rarely queried. Okay, and so there can be two things like we can so going by this, the data lake or S3 sort of a data storage is perfect. So if we can do like the Apache Parquet, okay, those kind of format, because they gives you a lot of good compression and a lot of good querying capabilities into the data engineering pipeline. So we can use it, we can use data lake for that. And when we are talking about the aggregated data, so in aggregated data what we are going to have is the best nature will be some sort of a time series data, because suppose aggregated for aggregated data again, ad id, maybe click minute window. So you give them a certain time and a window of 5 minutes, so maybe the click minute will be some kind of a timestamp, and plus 5 minutes time or 30 minutes time, uh, it is going to show that the total count, suppose the count is 125 in the last 5 minutes, this many number of ads were being clicked. So this is going to be a write heavy plus read heavy, because our end users will query like anything this data. They need to understand, uh, they, they need to keep on understanding what is the nature of the ad that is going on. But again, just to emphasize the fact that write will be more heavier than read here. So what we are going to have is like a time series data optimization will be best in this case. So for query patterns, like we can see frequent queries, and we are going to also see like the OLAP type queries, that is the uh, like sum, count, group by, those kind of scenarios, right? So for raw data we can now let's talk about the databases in detail. Okay, so for raw data, right, we were when we were discussing this part. Okay, yeah, so we can have RDBMS as well, but RDBMS will be not good for, not apt for write. Okay, this heavy write operation. Okay, so rather we can have things like Cassandra, or DynamoDB or InfluxDB or ScyllaDB, right? Because they provide columnar storage. They provide high write throughput, but again, the like we don't really know whether uh, this this NoSQL capabilities are also required or not. Okay, and then there are some things like, so RDBMS and NoSQL we already considered, and then there are something like data lake. So data lake means S3 plus uh, Parquet. Okay, something like in S3 we provide it as a Parquet, and for querying we can use like the data write will be very nice here in terms of the batch processing and the analytics, but the main problem is the querying. So for querying we need to use something like Presto. Okay, so there is tools like Presto or Hive, that can be Apache Hive, that can be used for querying. So like our recommendation for raw data will definitely be the Amazon S3 will with Parquet format, and we will use the Presto for querying the data. And for aggregated service, of course, like RDBMS, it has rich query capability, but the problem is RDBMS is again not appropriate for write. So RDBMS will not be ideal in this case. RDBMS is a big no. And then when we are talking about the NoSQL, uh, it is it is like in terms of the NoSQL, the time series databases are the time series DB is the perfect here because it gives us the time based what that is what exactly we need, time based aggregation. So Cassandra or like time scale DB, something like that we can use. So yeah, so that is something we can very easily we can very easily use in terms of our NoSQL. Now let's talk about our uh, design in detail. So now in the next section we are going to cover our design, and we will see which like we will see how the data aggregation service, how the raw data store, how the aggregated data store, everything will come together over here. Okay, so till this point, we have had a solid understanding like what will be the kind of a database that we are going to use, and what will be the basic data, not exactly data structure I would say, but what will be the endpoints that we are going to have. So now let's start about talking the basic high level design. So when I say basic high level design, it will be like what I will be trying to do is I will just draw some boxes, and from that boxes incrementally I will try to build the actual solution. So what will be the first component that in our application before sending the data to us is there will be some kind of a watcher service. Like what this watcher service will do is this watcher service will watch for ad clicks. So suppose I'm a user, I'm just clicking into some ad, and this watcher service will be responsible for sending that data to my corresponding database. So this watcher service is going to push the data to a data aggregation service. Okay, to a data aggregation service. Again, what this aggregation service will do, this aggregation service will do various kind of aggregation, like this watcher service is definitely going to pass multiple data, right? Like as we were seeing in the other place, like yeah, the ad id, the click timestamp, the user info, ip, country, all this data it is going to push. And from there what will happen is this aggregation service this aggregation service then it will further push the data to like after doing the aggregations, it will further push the data to the corresponding database. So when I say corresponding database means like just think our aggregation database that we initially thought. Okay, and there also after that will be a querying service. Okay, so uh, this querying service will reach out to database, and it will uh, it will be used for the visualization purpose. Now if you see this very basic boxes that I have written, forget about what exactly is in there in the aggregation service or what kind of database we are having. One core things that comes over here is this is a completely synchronous, right? So uh, why we are saying it synchronous, that suppose there is almost 1 million ads are being clicked, 1 million ads are being clicked. So what will happen is all these ads will all this ad will come into our aggregation service at once. Okay, so if there is a sudden spike in the traffic, so the problem with the synchronous methodology is in case of a sudden spike, aggregation service may not be able to might not be able to handle the load. As simple as that. Like 1 million ads if it is running, and suppose this is just some kind of a like a web API endpoints, or even if it is like under some kind of auto scaling group or something, still that sudden spike is always a problem for like major distributed systems. Okay, so this it will not be able to handle. And if also this is a s- single point of failure, so in case there is a single point of failure, in case this is down, all our push data will be totally lost. So suppose our watcher service, the way we have done is some kind of a WebSocket or SignalR or some kind of a server streaming to do towards our aggregation service. The moment it goes down as a single point of failure, we will see that everything has gone disarray, right? So that our entire pipeline will stop working and our data will be lost. So what is the solution to it? And in case you have watched my previous video, like just couple of videos back, the solution to this is very simple. That is, we are going to have a message queue or streaming service like Kafka. Again, I'll be careful using this message queue or streaming service this term, but like I'm not going to the details of the difference between message queuing, the streaming, and pub/sub. But in case you get a chance to watch my previous video on Kafka internals, you get the whole idea over here. So what kind of advantages it provides? It provides us some kind of a buffering advantages. And what it might do is, like, suppose it might tell that okay, only when like the 1,000 number of click event comes, then I will process. So this buffering I can take advantage of. And the like, in case I need more consumers or more producers, they can scale independently irrespective of the Kafka. And of course, in case the consumer goes down or the producer anything goes down, we do not really care because all the messages are being persisted in Kafka. Okay, so let's discuss about this thing in a little bit more detail. So what we have is, we have this log watcher, and this log watcher, instead of our aggregation service, we are going to send it to our message queue. So instead of aggregation service, what we are going to do is, we are going to sh- send it to our message queue. So this is our message queue. And from this message queue, what we are going to do is, we are going to send our data from this message queue to, in two places. One is first data aggregation service, and this message queue will hold raw data. So if you remember, uh, earlier we discussed our raw data, we are going to store in some kind of a data lake. So we can think this thing as a S3 data lake. And those who might not be aware of what data lake is basically a place where we can dump the data. As we just discussed earlier, like we can take different formats, like we can just think of like JSON or Apache Parquet. This kind of formats we can take, and we can just store our data in a raw format in the S3 data lake for auditing and for some validation purpose. And then this data aggregation service will be our consumer. So this is basically our consumer. And the advantage is, it will never be overwhelmed by all the messages. It will just take its own sweet time to do all the to fetch the messages from the message queue. And from data aggregation service, what we are going to have is, we are going to have something like different aggregation, like add count aggregation. uh, Also, we can have something like m most clicked m most clicked m most click add sort of a list. And what then we'll have is, this things will go from here to another message queue. Why another message queue is required, we will just uh, talk in a little bit more details of that. So this add count aggregation and m most clicked will go to this message queue, and this message queue will then passing its data. So here one thing I forgot to write is, there will be a writer service. Okay, so uh, like our Kafka doesn't have a direct facility to write into data lake, so some kind of a writer service will be there, and that writer service will going to write it to the data lake. Similarly, here also we are going to have our writer service. We're going to have our writer service, and what this writer service will do is, this writer service will send it to our aggregation database. Okay, so if you remember, we talked about our aggregation database, like we are going to have some kind of a aggregation or a time series database, like Cassandra or InfluxDB. So this is going to be our aggregation DB. Okay, this is going to be our aggregation DB. And into this aggregation DB, we are going to, like the querying and the visibility, query and visualization, querying and the visualization will be done by a user into our aggregation database. So if I just zoom out a little bit, this is the kind of a very high level design that we were looking at. Now we will go into the nitty gritty of it. Okay, so first of all, uh, like just a question to you: why two message queues? Okay, so we have to see that the message queue one that we have used. So if you just name it that q1, so this q1, sorry, so why two message queues? Let's discuss around this. This is going to be an interesting discussion. So suppose we are talking about the q1, okay, and why this q1 is being used? So it decouples the log watcher from aggregation service, okay, and it ensures that uh, lo- the click events are buffered during high traffic or spike, okay, and in case aggregation service or log watcher crashes, Kafka will anyway persist the data to a TTL. So when I say TTL, it means like time to live. Till a certain point of time, it will hold the data. And now this has been our Q1, and this has been our Q2. Okay. So this Q2, why it is needed? Now this decouples aggregation service from DB writer. How? So you see, if data aggregation goes down or if the writer service goes down, we do not have to worry about our persistence of the data, and it also helps in exactly one semantic. So aggregated results are written to database only after being successfully processed. So guarantee guarantee processing. Okay, so this is kind of a very core of this particular system that we have been talking about, that they are going to be two different Kafka or two different queuing mechanism that we are going to use. One is for the raw data and another one is for the aggregation DB. And there is again no thumb rule to think that okay, only because we are having two different databases here, so we are using two Kafka. But looking at the scale, the way this count aggregation will work, for example, this add count per ad owner, this is going to be really problematic if we do not make it like in a distributed manner. So as you can see, this end-to-end semantic, the idempotency, the transactional guarantee, all these things are being maintained. And also remember, like Kafka gives you a lot of other flexibility as well, like checkpointing, like buffering. So all those kind of advantages we will be able to use here. So what if without second message queue, directly from data aggregation service, we send data to the aggregation database? So what if without using second message queue, directly from data aggregation, we send data to our aggregation DB. What problem it will happen? Okay, so again, just to have more deeper understanding, so the problem that we will run into is aggregation service processes millions of events per minute, right? All the data will come, it will keep on aggregating it. So writing directly to database at scale can be overwhelming to the database itself. It might lead to like the database might get into a potential crash or the downtime. So without a message queue, aggregation and the database, so without second queue, aggregation or database might go into a major spike related issue. So in case database is handling a lot of data and it goes down, spike related issue, and if database is down for like 10 minutes, all the aggregation of that time period will be lost. So if there is no, just think in this way, if it comes directly from here to here and there is no in between persisting layer sort of a thing is there, then the problem that we will run into is, in case any of this aggregation, like in case our database is down, all this aggregation data will be lost uh, at that particular operational point. Okay, so now like we kind of get the idea, we kind of get the idea that like what kind of a database are to be used, and what kind of like why we are going to have the streaming layer or the message queuing layer and different streaming layer over here. Okay, so uh, let's circle back a little bit into what database we selected. Okay, so earlier we discussed around our database. So the database that we selected was let me just get it. So the type of database that we selected, selection. Okay, so let's talk about the raw data at first. Okay, so let's talk about the raw data at first. So what generally happen with the raw data is, each record like represents something like add id, click timestamp, user info, and user info can be some sort of a array. It might have a lot of data, ip, and some kind of a country. Okay, so we have all this all this data as our very raw data. Now for a very high volume, like suppose 50,000 QPS sort of a high volume, like in every single second probably 50,000 data are incoming. So in that case our daily volume is somewhere around 100 GB. And what kind of database is able to handle this kind of a load? Of course there are NoSQL databases, but we do not even need any NoSQL database, because NoSQL because there is a cheaper option available rather than using NoSQL. Okay, so what exactly is the cheaper option? That is, we can use S3 as our data lake in Parquet format. Again, Parquet is a very useful format which we can in data engineering, it is being rapidly used for very useful compression. And so the advantage is S3 can handle virtually unlimited data. So we will never unlimited data as a managed service. So this is a cloud managed service. So we will practically never ever run out of the data. So every day 100 GB data is being stored. That's a lot of volume, right? And what we can further do is to use this to use this data effectively. We can have tools like Hive or Presto. So what this things does is it helps us in batch processing. Suppose we want to query this data and we want to batch this data and then send it to our uh, send it for the data aggregation, okay, or send it to our the next level of queue. So we can use Hive, Presto, or even AWS have one out of the box solution called AWS Athena. And S3 is like, suppose I forgot the number, but S3 durability is really high. We are sure that we will never be run into a problem of missing our data. And also there is very important thing which is better than uh, any other NoSQL solution that is available in the market, that is the cold storage or the glacier storage. So what is the advantage of this storage is, suppose we after 180 days we understood that we are not going to uh, maintain this 100 GB data, so we will move 180 plus days old data to this layer. So the advantage will be like it is a really cheap data, and the only disadvantage is like to get this data there is a uh, certain waiting period is there, because it is been glacier storage. S3 takes some times to put it back into its normal storage layer. So this is on a very high level how we are going to handle our raw data. Okay, so this is the thing with the raw data. Then let's talk a little bit of more on our aggregated data. Okay, our aggregated data. So what happens with the aggregated data? So aggregated data will have things like ad ID, time window, uh, time window, or it can have region. It can have maybe region or other filters. I'm just putting it into bracket, region or other filters, and it will have then the count of click. So this will give me an answer that from US region in last 10 minutes how many click has happened. Okay, so if we see the volume over here for the aggregated data, the volume, it is lower than the raw data. Okay, for example, if there are 2 million ads are there, so what we are going to have is like for 5 minutes aggregation, we can divide like the 24 hours into all 5-minute chunk, and then do a OLAP style query. So OLAP means like online analytical processing, and in the OLAP style processing we can do the sum, we can do the group by, we can do the count, this kind of aggregations. Okay, so definitely the volume, it is lower than the raw data, and this is the basic query patterns we are going to use. Now why NoSQL we are going to use here? Because, and what kind of NoSQL? It can be Cassandra or Influx DB, time series DB. Okay, now why? Because the Cassandra can handle uh, very high very high, right? Like what I last read in the documentation, probably 3333 writes per second it can handle, which is kind of enough with the if we have a distributed, if you have a distributed cluster, this kind of latency and this kind of high throughput system is enough, and it is optimized for fast lookup, suppose add id in a certain time window range, all those kind of querying and lookup we can do. And it is also great for scalability, so it is horizontally scalable to handle growing data volumes. And of course the main thing is that time series support. So like automatic aggregation or expiration of old data. So this kind of things are really very much necessary for our system. That's why Apache Cassandra or InfluxDB or ScyllaDB is something we can go with. Now, we have a very fair idea regarding our database, what kind of streaming service we are going to use, and like what will be our endpoints and what will be our data. So one important aspects that I want to talk about over this before concluding our before concluding this video is there is a certain alternate design we can use. Okay. So what is the area of the alternate design? Now, in a generalist system design interview, we are not expected to know all the internals of the different pieces of the specialized software. Like for example, when we are talking about this data aggregation service, this is going to be some kind of a map reduce, it might be in some kind of a map reduce cluster, like AWS EMR we can use for the time being. So uh, here uh, like instead of having those kind of aggregation, there is a different kind of design we can also do. So yeah, we will just cover that. So here we have our log watcher. So log watcher, what we are going to do is similar to this. We are going to send it to our we are going to send it to our message queue. Okay, from log watcher we are going to send it to our message queue, and message queue then will be sent to something called a control engine. And what this control engine will do is this control engine will use some other technology to create our aggregation. So in this control engine we will keep on ingesting our data, and we will tell, so this control engine can be S3 data lake, and from this S3 data lake we can send our data to ELK stack or Elasticsearch. Okay, and this is very good for querying purpose. Alongside that, this control engine can consistently keep on sending the data to something called ClickHouse. So what ClickHouse does is it gives you a facility to OLAP aggregation. So OLAP aggregation is like it is a online, like as on the data keep on coming, it keep on aggregating the data on the fly. So ClickHouse or the Druid is something that we can use, and this can be one of the alternate design as well. But probably like the people who have used it data, like who are in the data engineering profile, they will be able to explain this thing in real detail, because in data engineering workflows this kind of stacks are very actively being used. So like if you have to design it from the scratch, I think this is the best design we can do. And if we think that okay, we need that complete OLAP, we are going to do a complete OLAP aggregation, then we can be more technology specific. Like we can use Elasticsearch for our querying, the whole ELK stack we can use, and the ClickHouse we can use for our OLAP aggregation. So that has been a fairly that that is fairly all the things that I wanted to cover, guys. Like as you can see, like we have covered the data model, we have covered the aggregations, we have covered the scale of the message queue or the scale of the database that we are going to use, and we also have we also discussed around one of the very important alternate design in terms of the click house, which is used for OLAP aggregation. So we are in a pretty good shape to conclude this video, and in case you have any question, please write it into the comment section. I will try my level best to answer that. Till then, uh, all the best. See you on my next video.